I'm joined here today by some of my close friends from NYU. And it's been a little bit of a journey, but first I want to give like a little context on what brought us here. So as you might already know, VAST has been providing data platform services to customers, particularly in the supercomputing space, for about 6 years. I've been at the company about 7 years, so I was here before we had a product and then found a way to bring it to everybody, and now it's out there. And over the last several years, especially over the course of the last several supercomputes, we've done a lot of innovation on the platform, starting with primarily just unstructured data storage, but then incorporating structured data storage in the form of a database, metadata catalog, audit database. And now we're extending the capabilities further with something that we call the data engine, which allow compute to run directly on the platform itself. And part of the reason that I asked NYU here today is because they're leveraging more than just one thing on the VAST data platform, and I thought it would be interesting for you to hear a little bit about their story. It goes back a ways. Like I remember actually installing systems with NYU about 6 years ago that they didn't buy. They did steal our cables, though. It's okay. We got it back later. However, more recently they have deployed VAST platforms in their data centers and are using them for a number of use cases, but I'm not going to go and bore you with those details. I'll let them bore you with those details. So if I could welcome up to the stage Lior and Carl, who are joining us from NYU.
Hey, Andy.
By the way, my name's Andy. Great.
That was nice.
Thanks for coming. Awesome. Thank you, Carl, for coming.
Andy. Thank you.
We can sit.
Oh, wonderful.
So, I guess I'll start with you, Lior. Maybe you could tell everybody who you are, what you do.
Hi, Lior Tar. Work in HPC and cloud systems for NYU. Last week was 20 years since I started, so been there for a while, watched high-performance computing start, grow, evolve, and become this monster that it is today.
Wow. How many supercomputes have you been to?
This is the third one.
Same for me.
Oh,
Yeah.
sweet.
Me too.
And Carl, how about you?
I'm Carl Evans. I've been at NYU for about 5 years now, primarily working on automation on the HPC side and deploying our Kubernetes cluster. So.
Awesome, awesome. Before we get into all of the new things that have been kind of going on, like use cases you guys have been working on, maybe for a moment if you could talk about what brought you to VAST in the first place in terms of deploying a platform, and what your experience has been compared to maybe experiences you've had with other things.
All right, so I've been working on storage and file systems for almost 30 years. We got a POC system, and we set it up. I remember the sales guy was giving us all these marketing stuff, and I was like, look, Paco, like, I don't buy the marketing. Like, let me see. So we got the hardware, started running various I/O tests. Well, got the hardware, set it up, super easy. Wasn't rocket scientist type of work. And started to fail a node, see how I/O would work. You guys had this concept of non-disruptive upgrades. I've heard that for years. So it's like, okay, the best time to do I/O test is when we're upgrading and C nodes are rebooting and all this stuff. Performance never dropped. And it did not take an entire week to upgrade. It was like 45 minutes.
That's okay, so I don't come from the parallel file system space. So I'm used to 45-minute upgrades that are non-disruptive.
I'm used to a week of nerves, anxiety, and hell, pain. Yes, exactly. And
This is like what you like to do? Nervous anxiety?
yeah, it's exactly what I love doing. Like, every time we have to upgrade one of these parallel file systems is when my nerves go wild, and then there's multiple PDFs, readmes. Oh,
That's what gets him out of bed in the morning. He
Yeah.
loves it, maintenance day. Like, he's just looking forward to updating those clusters.
yeah, it's just so much fun. And I mean, there was no crazy, like, software to install on the compute nodes. It was just build the RPM, install it once, and that's it. It was,
And that was slick and easy. And then we were dabbling with trying to find a platform to have our virtualization images hosted on. And we just basically tried any other storage that NYU had to offer for us, and the performance was crap. And like, we got VAST hooked up, and we're using Over It at the time, threw some images on there, and it just worked. Easy, fast, could migrate them across.
So then primarily were you using this system for HPC workloads, but then you also were running virtual machines off of it?
Yeah. And then you guys created that CSI driver, so then Kubernetes came into it, so.
Very cool. And then I guess, as time has gone on, well, I guess maybe for a minute, let's talk about a little bit, like what kind of research do you support? What are your users doing?
so we're central IT, and we're the cluster for all disciplines: chemistry, bioinformatics, biology, political science,
Normal things, mathematics,
mathematics,
science, physics.
I mean, so, and that's the thing. Usually in HPC, see, if you're doing like genetic sequencing, so you want very small I/O, and you have to customize your parallel file system for this particular I/O pattern. And for us, it was very complex over the years, maintaining a parallel file system and finding the sweet spot, because there never was a sweet spot, because there's large I/O, small I/O, all kinds of different I/O patterns, and VAST didn't mind. Like, it just, you give it, it took it.
Awesome. And then I guess the research that you support, well, I mean, I assume that your users do well-formed things. They run jobs that are always predictable. They don't do things that are abusive.
Our users are always on point, never cause any problems, nothing of that nature. No one's gonna bring the entire file system down by one of their crazy jobs. They never do that.
They never do that.
No.
No.
And so, in the past, with Lustre or GPFS, finding the node, finding the user that is creating the problem was rocket science. Like, at least at the time when we were using Lustre, it was going to the metadata server, going into proc, awking all kinds of stuff, sort, unique, count. It's like, oh, it might be that node. Then VAST had this thing called top actor. You go in there, it's like, oh, it's that node. Oh, wait,
That's
it's
the
connected to
username.
LDAP. That's the user. Oh, that's the job. Kill it.
S cancel.
Good times. Okay, so your users do dirty things, and you like to make sure that you can pinpoint what they're up to
Fast.
quickly.
Yes, because then the emails start coming in, the cluster's slow. The cluster's slow. It's like, yeah, we know, we're trying to figure it out.
So it's funny that you say all these things because, again, I'm used to things being easy like this. And I don't know why people would put themselves through all this pain.
Because there wasn't a VAST before.
Interesting. Good concept. Let's talk a little bit about the extensions on the data platform. So you start storing stuff. Primarily, you're using NFS for writing data. Do you use any other protocols?
Well, so with I mentioned the CSI driver going in, and then that opened up the opportunity to have object store, because you guys have a lovely S3 integration, and in a very beautiful way where I can create a file on the POSIX NFS side, hello world.txt or something like that. I can go do an S3 list on still hello world.txt. There's transparency on that level. So yeah, we're rolling out S3 options for primarily our Kubernetes users, but it's also available for the HPC side too. And then you guys built on top of that with your database. So we've got a data lake project going on in a pilot phase right now. And I mentioned it in context of S3 because the bucket policies are access to the table app. So that's pretty slick.
And so far, we only have 8.8 billion records in there.
Well, that's just
In
from
that
one team.
database table.
In that day, but yeah.
Well, it's interesting. So, like, and to give context, someone who can't be here today, who works for NYU, her name is Sophia. I actually met her at Supercompute in Denver last year, and they didn't know we had a database, and she heard the word database and started talking to me a little bit more about it, and so I spent a lot of time going back and forth and trying to identify use cases. So really, at NYU, as far as she was telling me, your team's providing a service layer so that your researchers and academics can go and run experiments and work on their projects and research projects. And now she's been engaged with one of the schools on a specific project. I don't know if you wanted to talk at all about that.
Well, so the big challenge is basically trying to add structured and unstructured data with structured metadata. We're trying to centralize, basically the data lake project is trying to centralize all of the university's research data into a single platform for researchers to use. And it's really easy to do on VAST because it's all right there together.
Yeah, she was exploring several different products that everyone's heard of in the market. None of them exactly fit, each one had certain parts, but it didn't fit exactly what our researchers needed. And then we were like, hey, and see, you're quite humble because we were running VAST. We were using NFS, S3, all great, and our sales engineer, James, is like, we're writing this database, and this guy just I don't know if he did it in a weekend, but it was one of those things where he's like, hey, we should do that. I think it would be useful for customers. And we were like, yeah, it would be. And it wasn't an add-on license that we had to do. It wasn't anything crazy. It was just another rolling upgrade, and boom, there's the VAST database.
Amazing. One thing that I thought was interesting about the research work that Sophia was working on was, so you mentioned the combination of unstructured data and metadata associated with it. So to give a little bit more specificity to it, first of all, the VAST platform has a catalog of all the metadata that's in the file system. That includes basic POSIX metadata like timestamp information, size, name of file, user, owner, that sort of thing. So you can do SQL queries against the file system if you want to think of it that way, right? Instead of running the find command that might take an eon, you can run a SQL query that would take a matter of seconds to return something that might be useful for either you or your users. But what Sophia ended up doing was kind of interesting in the sense that the project that she's working on is focused on sentiment analysis on social media. And social media, as you might know, isn't just text. There's also pictures and videos of cats and all kinds of interesting things. And so the media is stored as an object on the VAST data platform, and it has embedded metadata in both the S3 header as well as the tags that are associated with each object. Those are automatically indexed and put into the catalog. And then when she does any kind of insertion of the the social media post, the text associated with the post, that goes into a database table record, and she's created a lookup key to have lineage between which social media post is associated with which unstructured object, whether it be a file, like a picture or a media asset, and then there's metadata associated with it. So there's SQL queries that can run joins to identify, oh, show me all the cat videos that were commented on 25,000 times or more, or something along those lines, right? She wasn't actually doing cat video research, though, was she?
Correct.
We don't have to talk about what she was doing. It's a little bit more nuanced than that. But having a file system metadata catalog that's consistent with the file system means that there are things you can do that would be much more difficult to do if you had to manage all these pieces on your own. But in addition to that, you mentioned a data lake project. What kinds of, we'll call it applications, do you support for that data lake?
So another one that we're adding, it's a joint project between NYU and I think it's Michigan. I might have the wrong university in there. So what they're doing is they're starting to archive and catalog all papers that were published so that there'll be a central point, the papers and the data, so that there'll be a central point for researchers to find any kind of paper that was published and the data set that was related to that, so that if anybody wants to reproduce it, do analysis on that research, it will be accessible right there on the VAST platform. I mean, no one will really know that it's VAST behind there, but there will be a central place where researchers can go and pull down papers and most importantly, the data sets to reproduce it.
Interesting. And I guess, are there things that you, I guess, hope to do with the platform that you've thought of that you haven't implemented yet? Any ideas that come to mind?
The data engine, he's definitely got ideas.
I'm pretty excited eventually, because you guys started introducing this eventing, so now if an object is created, we can trigger a cloud event to actually start a workflow potentially. So we haven't really started playing with it yet, but the ideas are starting to rattle around in my head there a little.
Awesome.
For, doing some of the automated cleanup for just life cycling out objects for scratch space for users, or an object that's dropped here, we trigger a new workflow either on the HPC cluster or on the Kubernetes cluster. So that's really cool.
Do you guys find that objects is becoming more and more prevalent with what the researchers are using?
I'm trying to make it more prevalent. It's, HPC, we're a little slow going sometimes with, we have our comfort zone. But the accessibility of objects, it's everywhere. It's, I feel like, it's the researchers will adopt it.
Are you guys working with the library at NYU to store these papers and data sets together? Is there some way of doing catalog through it? Do they have a system for that?
The library has their own archival system that they use. This is a new project that they're working on. So this will eventually be stored on the VAST platform, not associated with the library, but I don't know if there are any particular conversations between the library and these researchers. You're welcome. And so the one thing that is important to note is with VAST, it just works. We were having a chat with Alon yesterday, and he's like, look, I ask customers, what do you need? What's broken? It's like, no, it just works. Just the fact that it works. And okay, so he's done the upgrade. He's now a storage admin. So
Definitely not.
How simple is it to upgrade? He's now a storage admin. We've had 2 other new hires, and I was like, hey, do you want to upgrade VAST? And they're like, no. It's like, no, go ahead, do it. And they did it, and they were like, holy crap, that was easy. Does not take a rocket scientist.
I'm curious, like when you do upgrades, do you go tell your users to stop doing what they're doing?
Nope.
We don't even tell them when it's happening.
Yeah. And they don't even know that it's happening.
You do it on like Friday night in the middle of the night?
We have Friday YOLOs. But no, but we just, whenever it makes sense, we have the time, we just do it. We just mention on the Slack channel to our team that, hey, by the way, we're upgrading VAST. It's like, oh, cool. All right. Thanks. We do not have to tell the users because it's not one of those things. And
They don't notice.
again, it doesn't take a week. Like,
So it's fast, it just works.
Stupid easy.
People don't complain. Well, people complain. I mean, it's what people do.
analytics. Okay, so the last time I've seen analytics this good was in the ZFS appliance that Brendan Gregg wrote. He associated it with dtrace, which is kind of now more like eBPF. And when I love to see data and I love analytics, and I went in there, it's like, oh my God, look at all the values and data points I could look at. This is great.
It's almost like you teed it up for me, actually, because you mentioned eBPF. So I was actually, I met with a customer who's also in this room about 2 years ago, and they said, well, we love that you have all these analytics that we can see who's doing what, but I don't know which job is running this I/O. They have a single user for all of the applications that are running, so it's not as if you can say, oh, this user is the problem, because there's only one user. And we said, well, the NFS protocol doesn't have like a facility to put things like a job ID into the wire level protocol, so we don't know about it. So we've been thinking a lot about how to do this, and then what I did, I have this dirty trick I do at Supercompute every year, which is when our VP of engineering is sitting in a meeting room with me, I ask customers if they want this feature that I really want us to do. And they always say yes, and then he has to do it. So that's what happened is I basically went around shopping this feature around to many of people who, and some of you I've met in the room probably, and everybody said they would use it, which is, can we have a way to take job identifiers and associate it with the I/O that's hitting the VAST cluster? And so now the answer is yes. Now, we are doing it in 2 phases. The first phase is we have basically a little lightweight RPM or a Debian package. We're compiling more, and we will open source this as well, which uses an eBPF filter to basically capture any events that pass through the kernel into any NFS mount that's on your client. So you install it on all your clients, and then when they capture these events, there's a config file, a little YAML file you put on the client that defines which environment variables you want it to capture when it's collecting these events. And it could be whatever environment variable you want, we don't care. And then it takes the environment variable and all of the tuples associated with the I/O, so the user ID, process name, process ID, all of those bits and pieces, as well as the I/O type, as well as the amount of calls and the amount of I/O. And it takes that information and it can forward it to one of 4 different destinations. One destination is local files, which is not that useful. Another destination is it can go to a Kafka topic. Another is it can go to a VAST database table, big surprise. And then the last one is Prometheus. And so you can basically get all these statistics forwarded straight to a collector that allow you to perform analytics to know which job ID and user are causing the I/O that's hitting the system. Now that's phase 1, because there's something missing from it, which is the fact that it's not in the protocol stream. And we have another customer we're working with where they need it to be in the protocol stream because they want to do quality of service based on job ID. They want to be able to say, by default, jobs get this much I/O, but I can give exceptions. Or as this job starts to run I/O, maybe they can go put a QoS policy in place that will throttle how much I/O it does. But in order to do that, we're going to do a little bit of extra extension with the NFS4 protocol, but that's going to be coming later next year. But right now, if you want, you can send me an email or a text or a Slack or whatever, and I can give you an RPM that you can try out on your systems. And it doesn't even require a VAST cluster. It could work with any NFS mount, but ours is better. And so I'm happy to show you a demo either on my laptop or at the booth 1722, if you want to stop by our booth. I mean, would you use it?
Yeah, send it
Andy,
to me.
I want.
I already
I
asked
want.
you for that,
I
I think,
want.
the last
You
time.
didn't ask me, I forgot.
I want it. I need
anyways,
it.
You need it?
I need
Yeah.
it.
What are you going to give me for it?
We're-
Already gave you something.
All right. Well,
Quid
if
pro quo.
there's no other questions, I'm happy that you guys came up here and did this with me. It was a lot of fun.
It was a delight.
Agree.
Awesome. Well, thank you so much. Let's give them a round of applause. Yeah.